Today, the Bozeman Chronicle reports that there are a dozen new COVID cases at Montana State after a week of school. And I just wanted to share how I'm thinking about that in the context of an epidemiological model. This is a high-level view of Ventana Systems' 50-state COVID-19 simulation model. A couple of weeks ago, I used this together with 50-state COVID tracking data to estimate the prevalence of infection, the true prevalence, not the measured by testing number, uh, across the United States, and weighted that by the incoming class composition at MSU to figure out how many infected students were likely to be on campus in the first week or so of operations. If you look at the 50 states, this is prevalence in 10 of the biggest states plus Montana. You see Montana is pretty low. Um, so you might think actually that there's a big infection pressure threat from other states, but actually it turns out that the composition of the student body is such that the average incoming student has a probability of infection that's not much higher than the average Montanan. So I'll just quickly walk you through how our model works. At the top here, we have the SEIR model, or a slight expansion of that. So we have susceptible people, exposed people, infectious people, actually broken into two categories, pre and post symptoms. We have people with ongoing illness, and finally recovered people. A certain fraction of those who are infected actually wind up in the hospital. An even smaller fraction of those, particularly in the 20 to 30 set, die. Obviously, the faculty and staff of the university are at much higher risk than the students. And the infection process is essentially the two stocks of people in this red box, the pre-symptomatic infectious and the active symptomatic infectious people who are out there socially active, contacting other people and infecting them. So an infection takes an interaction between someone who's infectious over here and someone who's susceptible over here. At the bottom here, we have a parallel chain of people who are exposed or infectious or hospitalized who've actually tested positive. So this is essentially the accounting system for cases and is what leads to the reports that you get on the county website about the number of infections that have occurred and hospitalizations and deaths. So this is the measurement system that represents what's happening in the underlying population. So when we test, we go out and we sample a person. So say they show up at a clinic with symptoms. You take an infectious person. If they test positive through this flow, we move them into the accounting system for the positive infectious people. So the challenge basically is that if your test density is not high enough, you can't find all the people who are actually infected in this part of the chain. You only know about a portion of them, and it actually might be a pretty small fraction. It may only be 10% in many cases. And in particular, the very early exposures are problematic because they don't have enough viral load to test positive, and because you can't find them. Your contact tracing processes and testing and reporting processes all involve delays. And so for the first couple of days, you may not have had any way to discover that these people even exist and get them tested, unless you have really ubiquitous surveillance of the disease. So generally, you can think of the people in this part of the chain as the tip of a substantially bigger iceberg that's up here. Probably not so much for hospitalization and deaths because there's now pretty ubiquitous testing in hospital settings. Uh, but if you really want to appreciate the extent of disease that's out there, knowing the number of active cases or recently discovered positive tests dramatically understates the actual number of infections that are out there in the population. So, what are the numbers like here? Um, well, my estimate using the full 50 state model and the student composition of MSU was that the incoming class would have something like 150 students in the infectious, or actually in the infected boxes. So something like 150 in the blue box. So these are people who arrive in the incoming classes who have the virus. Probably the number of those that you would actually know about is small. Uh, Hopefully, not many are going to be foolish enough to show up on first day of classes feeling sick um, or having very recently tested positive. Um, so this number's pretty uncertain, um, but normally you would imagine that there might be a 10 to 1 ratio of measured infections to actual infections. So the number of these that are discovered even in the best of circumstances is probably pretty small. So you've got 150 students in the student body of 16 or 18,000 this year, I think, and then in addition, you've got about 4,000 staff and faculty. So what's the fate of those? Well, if you just look at the time constants of the infection process, um, the residence time in the infected system might be 2 weeks. So you'd expect an outflow here of about 75 per week. So now the big question is, what is this number? If the number of infections is less than 75 a week, then the infection is going to die out in the university population, and basically everything will be fine. But if it's higher than 75 a week, particularly if R naught is or RT is uh, is 2 or 3 as it is in kind of the uncontrolled disease, then you're getting a couple of hundred infections a week, which means that the infected population is going to grow rapidly. Um, so here's the problem: the number that we've just gotten from the Chronicle article based on county stats is that so far we found a dozen infecteds. So basically the sum of this flow, and this flow, uh, and maybe this one, but presumably hospitalization's not involved, is 12 a week. So that's potentially encouraging, but I think we basically can't draw many conclusions from this number because we don't know how many tests led to that. So if you think of 10 to 1 between known infections and unknown infections, that would suggest that were maybe 120 discoverable infections initially up there, which is pretty consistent with my guess from national prevalence and student composition of 150. So this might be simply what you'd expect based on the number of cases that moved on to campus in the first week. But I think, unfortunately, this doesn't yet tell us anything about the number that we really want to know, which is the number of new infections, because simply not enough time has elapsed to understand what's happening. There a lot of anybody who was infected in the first couple of days of this week, for example, is still in this box where they're hard to discover through testing and contact tracing. They certainly don't have any symptoms, and therefore they're likely to remain unknown to the system. Um, so uh, if we knew for sure, if this number, for example, were 12 infections per week, that would be fantastic news because that would mean that all the controls were working, that the good mask compliance seen on campus and the good hygiene and the hybrid online and sparsely populated classes were all working. But I think it's simply too soon to tell. At the same time, it's too soon to panic. So I think keep watching and waiting, and apparently testing is really going to ramp up next week, which will give us a much better read on sort of what's in these boxes, because we'll be sampling them much more quickly, and therefore the kind of the visible part of the iceberg down here is going to get bigger relative to the unmeasured part of the iceberg up here, and we'll just have a much better sense of what's going on. So I think that's the state of the system at the moment. Unfortunately, it's inconclusive, but it'll be interesting to watch this closely and see what happens in the next week or two.